going to be, I'll try to tailor this a little bit to the different crowds. The people doing software estimation because they want to, or they need to because they're, let's say you're your own business, or you're the sales team, or like especially if you're independent, you're every team, right? That's one place you're coming from. So those to you, estimates to you could be revenue, right? In other cases, they're deadlines that you're going to get held to. So we'll talk about kind of all those things. So hopefully there's not a ton more people outside. So we'll wait a few more minutes and we'll get started. But if you have other things you want to hear about, shout them out, and then I'll try to cover them. So it's a great front row seat. You're arching your neck, craning your neck. I'm kind of curious. So this is the first year that you got stuff in the mail. The registration process seemed to go smoother. This is totally unrelated to my talk. Who here kind of didn't get a badge or had issues? Like, if I ask who had it work well, it'll probably be most people. How many people had issues? It's not bad, really. Like, there's like 3 or 4 hands in the entire room. That worked a lot better than could have.
Everybody, this room's pretty full, so if we could defrag a little and move towards the middle so that new people coming in have a place to sit, that'd be appreciated.
That joke's not going to make sense in a few more years with everyone on SSDs. It's going to be like the floppy disk save icon. No one's going to know what it is. So that laser's not going to be real useful up there. If I need to call on you, I'll shine this right in your eyes, and then you'll know I'm calling on you. How's it going? I can't make chit chat with the mic on, so yeah. Are you ready? Do you have one of these? All right, we'll wait like 2.5 more minutes. Anyone having trouble seeing the 150-foot screen? Any issues there? You're going to have to straighten, in the front, you'll have to move your neck side to side to see everything. So. Yeah. If you fall asleep, I will point the laser pointer right at you. What's that? Oh, yeah. Yeah, this talk will take somewhere between like 30 minutes and an hour. I don't know. I'm not sure. I'm guessing. Might be 2 hours. I don't know. Should put question marks after my name and everything else, too. Yeah, exactly. Yeah, that's right. There's one seat right front and center. It's a good one. I was kidding, but you can take it if you want. I'll hand you the mic, Willie. You can say that in the mic. So, all right. We are just about ready to get started. So if you haven't guessed by now, if you're not here for software estimation, then you are in the wrong place. Let's briefly cover about me, and then we'll get into the talk. So about me, I work for a consulting services company in Columbus called HMB. We've about 200 employees. We do everything from custom application development to BI and other stuff, and I'm our Microsoft practice director, unless I'm talking to a Java shop, and then I have another title, because Microsoft's not good. So I'm involved in a few different conferences. One called Stir Trek you may have heard of. I made a phone call. It was great. That's all you have to do to get a red shirt. I'm a co-founder of a conference called Cloud Develop. I'm involved in the Dog Food Conference, which is a one-day or a two-day Microsoft-focused conference in Columbus. Microsoft MVP on the Internet Explorer team. I'm hoping I get to be called an Edge MVP because that sounds way cooler. If you haven't heard about that, that's the new browser. It was called Spartan. Spartan MVP would be awesome, but that's just a code name. And I'm a gigantic nerd. I'm a gamer, video games, board games, and that's enough about me. So we're going to use a few different characters to talk about, or to do today's talk, just to kind of sit in for having like team members. So we're going to have designer, creative spirit, already has an Apple Watch because he's that kind of person. He's gonna kind of fill in for BAs, QAs, the other non-code people on a team. Part of this talk is to make sure you're thinking about all the other roles that happen in software development. So they need to be in your estimates. So the work that the designer, the tester, even if they're one person, the work that they're doing, those roles are doing, are important to be in an estimate. We're going to have developer. So the person who, if given a week, can solve it in a week. If given 6 weeks, can solve the same problem in 6 weeks. Right? That's all of us. And the one you solve in 6 weeks will have a lot more code than the one you solve in 1 week, but it'll do the same thing. So, and I asked this earlier, but we've doubled in size. Who's a developer? Who'd say they're a developer? That's okay, most of the room. So hopefully this is relevant to you, but also relevant to other non-developer folks. Okay, so the software development process. This is going to be an abstraction, I guess, or a simplification. Somebody has an idea, right? If you have an existing app, it's a feature. If you have a brand new app, it's maybe the founder came up with an idea, and they add some stuff to it, and there's details there. And the stuff gets added, right? Because all software, when it's on a whiteboard, is free and has an infinite scope. So you'll just add more stuff until at some point something changes, a new character appears. The person who has to cut a check or is responsible for the budget, the boss, right? That person will do the thing, ask the question that no developer likes to hear. How long will it take, right? They ask that question, and they might ask it all the time. And if there's a fire and something's down, they might ask every 15 minutes behind you, and they're standing behind your shoulder watching you trying to fix it. So the question, how long will it take? No one ever likes to ask this, but it's important. They're asking it for a reason. Generally, it's not just because they don't like you. Why does that question matter? First thing is, you don't work in a vacuum. You're building software because it's valuable to someone, right? If you're building stuff on your own, you're doing it because it's valuable to you for some reason, for training or to learn a new technology, or just because you want to build an app or something. Generally, you're doing it because there's a business that's there that wants to get more value out of the software than they spend on you building it, right? So you're working for someone not just because they like you, but because you're adding value. If the project you're working on loses money, if it doesn't return more than you're investing in it, the business or whoever has that money would be better off doing something else. So if your return is really, really small, they'd be better off taking their money and sticking it in a money market account or something. So they're investing in you to build software because they think they can get more value out of that software than they're putting into it. All right? So there's a business side to everything we do. I think we forget about this a lot in software development. And if you don't have estimates and you don't have targets, it's really hard to look back at a project and say whether it was successful or not. Just because you finally shipped the product doesn't mean that it was a good idea to build it in the first place if it costs 8 times as much as you expected, right? So they give you a way to measure accuracy. So the boss asks that kind of question. What do developers do? They run away as fast as they can and try not to answer it. And the boss is like, what just happened? The boss thinks it was an easy thing to ask, right? Software estimation is important for 2 things. The big things, like whether a business is even going to do a project at all, or whether there's a question in the back about prioritization. They have 6 projects they want to do, but they don't have enough money. Which one are they going to do, right? If they don't get a sense of the size, they might decide, oh, this one's the highest priority, not realizing that they can't finish it in the budget they have. Once they have a sense of the size of projects, they may reprioritize, even if one would be ultimately better, because other ones are more feasible, right? So this can be, estimation can be part of a go, no-go decision. It also can be used for small topics, so your iteration, right? The features that we're going to build in the next 2 weeks, right? So not the, are we going to do this multi-year initiative, but can we commit to a set of stories by the next release, or the next 2 weeks, or the next testing window, or a trade show, or something like that. when I asked earlier, a lot of people are doing estimates at that level. I'm not sure as many people are doing them at the global scale. So they're important for both, and we're going to talk about both. So today's topics, we're going to I'm sorry, I'm going to read this slide, but I won't read most of them. What are estimates really? So what are they even kind of in concept? Why do teams hate doing them? Why do they want to avoid them? Prerequisites to estimating, so things you need to know before you can put together any sort of accurate estimate. Types of estimates and how to perform them. We'll cover 3 different types of estimates. And how to use estimates to improve communication. A bunch of the questions early kind of touched on this. Estimations are a tool for giving you a number, right? But they're more than that. They're a way for communicating between a developer in a seat and the CEO at the top of a corporation. So we're going to talk about how they can be useful and how actually estimates can be used to protect your development team and not just like hold them accountable. So what are estimates really? Let's look at a definition from, I think it was dictionary.com. Let's look at number 4. An approximate judgment or calculation as of the value, amount, time, size, or weight of something, right? So approximate's a keyword. It's a best guess, right? Also, number 6 is pretty decent, especially if you're a consultant. A statement of the approximate charge for work to be done submitted by a person or business ready to undertake the work. So that's what estimates are, right? They're your guess at what something's going to cost. If you're doing fixed fee consulting work, they might be the price you're going to be held to. But you don't have all the information yet. You haven't built the project. Your estimate after the project's done will be perfect every time. So if you get the time machine thing working, you're golden. Let's talk about how estimates are perceived. They're perceived like this. They're perceived as the scope, schedule, and budget that define if your project is successful or not before the project even starts. They're set in stone no matter what happens, right? That's how a lot of teams perceive estimates. A lot of that's a communications problem. Some of that you might be able to overcome. Hopefully I'll give you some tools for that. Some things you might not be able to. So how do we make them work? There are 2 things that we need to work on to get better at estimating and making them valuable tools for your organization. We need to get better at estimating itself, right? Building the estimates, and we need to get better at communicating. So I'm going to keep harping on the communicating term. First thing, something you have to buy into for any of this to be valuable is, can you be good at estimating? Is it a skill, or is it just blindfolded people throwing darts at a target? So my argument is it's a skill, like programming, like public speaking, like designing, like anything basically in life. You might have certain people who start off a little bit better, but like any skill, you can improve, right? You can train yourself, you can get experience, and ultimately you can become a lot better at estimating over time. Generally, the things I'm talking about won't be really relevant to a junior developer, somebody just starting out, because they don't have a lot of experience and context. The person who has, one way or another, estimated a lot of projects or seen a lot of projects through and seen what they took to build will be better at this. The person who has data that they've tracked in some sort of tool will have an even easier job. There's, and I can speak from experience, that in the last couple of years, I've been doing this a lot. So I've spent some time researching estimation, but also it's a big part of my job. Because we're consulting and people want to know how much it's going to cost to do something. So I've seen myself get better, right? Not perfect, but better. Because it's a skill, there's things you can do to get better at it. The first thing I'd recommend, the book that gets described as the Bible of software estimation, is Steve McConnell's Software Estimation, Demystifying the Black Art. It's really accessible. It's fairly inexpensive. I want to say paperback is around $30. I like this because it covers a lot of different topics. I'll reference it a couple times. And while there's stuff in like PMI for project managers or IEEE, they have individual things that you can use for software estimation, guides they have, and there's a lot of blog posts. This is the best reference I've found that kind of pulls it all together. So I really like this, and if you're interested in software estimation, it's actually it's an interesting read and it won't put you to sleep. And it's got pretty pictures. So another piece of estimating is the objections that teams have when they push back, right? So the boss says, when will this ship? And this is something I've actually heard before. Who knows? We're Agile. We don't know, right? And the bosses love that too. That's great. So there's a few different arguments that people have and objections they have, right? Requirements change too often. So we can give you an estimate, but it's useless tomorrow. We'll talk about how we deal with that. We don't want to be held accountable. I've never heard anyone say that just like that, but I've heard a ton of people say things that boil it down to, if we give you an estimate, we know we're going to be held to it, and we don't want to be held to it. So we're going to make up some sort of random t-shirt size thing that doesn't mean anything to you. And I don't mean to make fun of the Agile process there, but that's what managers will think, right? You move to something besides hours, but I need to know hours. So they don't want to be held accountable. There's a lot of that. we just don't do estimates. We never have. We don't want to start. We don't know how to. And I needed a filler. So let's start with Agile shops don't estimate hours. So Agile teams tend to think at iteration level about estimation, right? The bosses still might be needing to plan, right? So there was a question in the back before the talk about if you have 6 projects, how do you decide which one to do? If they don't have any sort of estimate, they may choose the wrong one. If they're looking at features, so let's say you're a product company and there's a trade show, and the sales team would love to have a certain set of features at the trade show. If it's not possible to get those out in time, they'd probably love to have some other set of features at the trade show, right? Maybe not the ideal ones, but something they can show. If they prioritize and then you estimate, they are going to have trouble necessarily getting what they want, right? So they need those to just make business decisions. They might need to decide, hey, do we even build this thing versus buying some off-the-shelf software, right? That might be the right choice for the business. If they don't have an estimate, they won't know. So I like the idea of we won't design everything up front and we'll deliver things and get feedback, but sometimes you need to do just enough design and just enough estimation for somebody to decide if the project makes sense to do at all. And I like to say the CEO doesn't care about the Fibonacci sequence, right? He cares about costs and timelines. So at some point, someone in the business is going to be thinking about those things, whether you're doing it or not. And we'll get back to why that could be dangerous. We can't estimate because requirements change so often. So how can you decide whether to make a change or not if you don't know how much it'll cost, right? If the business owner comes to you and says, hey, we were going to build this screen, maybe you've built it and you've shipped it, and we want to change it totally. If they don't have a sense of the impact of that, they're going to do it every time, right? If every change is impact list, there'll be an infinite number of changes. So if you can go back to them and say, hey, the first one we built took 2 weeks, and the changes you're requesting take a week and a half, they may say, oh, well, maybe I don't need that right now. Or we'll put that in the backlog. Maybe you can suggest put it on the backlog. The backlog is a great place to kill dead features and bad ideas, right? Oh, we'll get back to that, but there's this other thing that you said was a priority yesterday. If you don't have estimates, it's really hard to communicate the impact of the decision the business is going to make, and they're going to make bad decisions. So we'll talk about this more later. As circumstances change, re-estimate and use that as a way to talk to your business in terms that they understand. If we don't estimate, we won't be held accountable. Here's the terrifying thing to me. Somebody is going to do an estimate. If it's not the developers, it's not the developers, right? It's someone else that's not writing code who's doing the estimate, and then you're going to be held accountable to it. So if you really want to kind of guard your behind, the best thing you can do is make sure that you have a stake in that process, right? And it's not somebody at 10,000 foot level saying, oh, that seems pretty easy, we can have it done by next Friday, and then committing to the CEO. I was just recently talking to someone down in Louisville who did some work for the military, and they had somebody commit to a general that something was going to be done in a certain time frame, right? You don't want to tell a general that you got it wrong, right? So you want to make sure that you're involved in this process so that the estimates that get created are reasonable. If you don't estimate, you will be held accountable, and they won't be achievable estimates. So how long will it take? First rule of estimation is never, ever, ever answer this question immediately. You need to put some sort of thought and methodology into it. If the boss corners you at the water cooler and asks us, the answer is, I don't know, I'll get back to you, right? Because without some sort of rigor, you're going to miss things. And we're going to talk about all the types of work that are involved in an estimate, and I'm hoping you'll look at that and say, oh, I wouldn't have thought of that, and kind of get a sense for why it would be bad to just tell them. It's one thing if they say, hey, how long will this text change on a page be, and you kind of think through and say, oh, it'll take 8 days because of our process. Generally, you'll say, oh, 15 minutes, and they'll hear, oh, 15 minutes will get it in production, right? Well, if you're in a big enterprise, 15 minutes will get it in your source control, maybe, right? So don't ever answer that question right away. Answer, you'll figure it out and get back to them. And it buys you some time to panic too. And then you sort of say, oh, what do we do? So how do we get started? There are a number of things we need to build an estimate. We need scope. So scope is the features at a high level, not business requirements, but just what is the thing you're building supposed to do? If you don't know that, you can't possibly estimate what it is, right? And so if you can talk through your estimation process with the business, and they ask you to say, hey, I want a page that does X in a sentence, and they ask for an estimate, if you have a somewhat defined process, you can go back to them and say, I can't give you an estimate yet because I don't have the first steps of the process. So you need to know what it's supposed to do, and also, as importantly, what it's not supposed to do, right? What is and is not in scope. You need to know constraints. So these are things outside of your control, but that you're reasonably sure you know. So an example of this would be, we're going to build this thing, and we're going to test it locally, but we're going to deploy it somewhere else. So I worked for a company where we built all of our code in Ohio, and we deployed it to the Southeast. And Big Ten code does not usually work in the SEC. It just doesn't. For whatever reason, it doesn't like it there. Yeah, exactly. The SEC gets jealous, and then, these are constraints, right? You say, okay, this is going to deploy somewhere else. Things may happen that are outside of my control. I can't estimate those. They may change too, but you think you know the constraints. You also have assumptions. So these are the things that you know you don't know, and so you're going to just make assumptions so that you can do an estimate. So these could be, let's say you're integrating with a third party, and you don't know what their API looks like, but you have a sense from a phone call that it follows some standard. Who here works with like EDI documents, right? So every single one of those is done differently, in my experience, right? Every single vendor is different. So you might make an assumption that this version of EDI is similar to one I built before, and if you detail that and it changes, you can point back and say, timeline's going to shift because this assumption was wrong, right? I have something documented that I explained to you as a business, and it's different. Our projects can be different. You're not going to know an awful lot about the project before you start it. So you should have a long list of these. And when I say list, I mean written down somewhere. It should be a communications tool for the business before you start the project. So you say, here's what we think we're building. Here's what we think we're not building. Here are the things that we're constrained on, and here are the assumptions we had to make. And then from that, once you get agreement, then you can do an estimate. I like to get sign-off on this. I like to send this to somebody who's in decision-making, has a decision-making authority, make them sign. But even if you can't get that, let's say you can't get the main product owner to sign off, if you can get somebody in the middle, at least you have some traceability later to why things change. That person who signs off on it, when there's a change later, can come back and say, these 6 assumptions were wrong, and that's why we didn't hit our deadline. This can cover your back, right? So you need these 3 things: scope, constraints, and assumptions. So let's talk about some estimation methods. We're going to go from easiest to hardest. The very easiest is just throw dice, right? Random dice. We're not going to cover that. You can figure that one out. There's dice. You got them. Actually, they're sent to you for the conference, right? That's what you use them for. There's 3 estimation methods we'll talk about. There's other ones out there. There's tools, really robust tools that are well beyond my ability to describe. The 3 estimation methods I'm going to talk about cover all of the work, or should cover all the work involved in the project. And if you don't cover all the work, you're going to be short. So here are some types of work that might be involved in your project. There might be others, and your team might call it something different. But there's planning. There's knowing what sort of reporting you're going to need, making sure your tools are set up, making sure you know who your people are, that there's something that might be considered project management work. There's requirements gathering. It's like taking the feature and down to stories that somebody can develop, right? And it could be a developer who does that. It could be a BA does that. It could be something else. There's design work. It could be mock-ups and wireframes. It could be data flows. There's the things other things you need to be able to build the application. There's the development itself. Dangerous habit for developers when asked how long something will take is to just give the development number, right? And forget all the rest of this work. That's why I'm going to keep harping on all this stuff. So development is a big piece of it. And most of us in the room would consider that the critical piece, but it's not the only piece. There's testing, right? Software has bugs. It's a part of the software development life cycle, right? There's going to be things you get wrong. There's going to be things that your assumptions were incorrect. There'll be things that you would not consider a bug, but a product owner might once they see it, because the thing they had in their head didn't quite map out to paper or to the screen. Documentation, knowledge transfer, training, all those things, deployments, like how do we get this into another environment? Your team may not do that, but it's part of the overall work. There's other stuff that we could be missing. Anyone have any examples of things that you'd say would be different that aren't up here? Because I will steal that and put it in my slide for next time. Support's really good, yeah. You might estimate that separately, but that's part of the work, right? And you might say, we have a warranty phase, and we need to account for that. And they might think, you're going to be done in 3 weeks, and it'll have been in production. And you're thinking, oh, no, I'll just have pushed it to the servers in 3 weeks, right? So support's great. Anything else? Reporting? Okay, yeah. So our app collects a ton of data, and you want to build reports off of that, right? So maybe it's a separate project, and you'd say, okay, in the scope, that's out of scope. But if they assume that it's in scope, and you didn't build it, you're not done. Yeah, great reporting is great, too. Yeah, so you're building a new app that replaces an old one, and you need to get all the data across. Yeah, who's forgotten data migration? Yeah, me too. That's a great one. I just forgot it now, too. That can be as big as the project, right? If you have garbage data and your new system is totally different, and you forget to include that, you're going to be in a world of hurt. Yeah? Oh, yeah. Okay, so you've given them a timeline, but you get pulled aside, right? So your total amount of work spent on a project may be right, but if something breaks, you may still spend the same number of hours, but you don't get it done on the date they wanted, right? Yeah, so you have to account for that. Right. Okay. Now we'll talk about that briefly. Don't include that as like a padding. We got to figure out a way to communicate that better. Definitely not idiot tax to the client. But I see what you're saying. Yeah, there could be costs. Actually, a good example would be certain industries, right? If you're working in aeronautics, you're probably going to test way more than you're going to do if you're building an intranet app, right? Because a plane could crash or something, or if you're doing medical device stuff. So there's industry-specific things that could increase the cost of something. Financial transactions that could cost money, right, are a lot more important than a document got moved. So, yeah. So there's definitely some things here, and I'm going to try to remember those afterwards and add them to my slide and steal them from you. So thank you. So if we tell the boss 2 weeks, and in 2 weeks testing starts, right, for any of these, or 2 weeks, one of these isn't done, we're not done and they're not going to be pleased. So we need to make sure we account for them all. And you'll probably get it wrong the first time because you'll miss something, right? I missed some putting the slides together. So we'll talk about this. So types of estimates. SWAGs, scientific wild-ass guesses, right? The first type of estimate, this is the closest you should ever be to giving somebody the water cooler estimate. So if they ask you for something, they just want to know, a good example, I've worked with people before who said, yeah, I have this idea for a small feature, how long would it take? And they were thinking weeks. And I'm like, that's like machine learning. I don't know anything about that. A year? They're like, really? I'm like, it's not simple. It might not be a year, but it's not simple. And they said, well, it's really not that important. I just thought it would be kind of cool. This is useful for that kind of thing. And that happens, right? They think it's nothing, and you say it's huge. Or they say, it'd be critical for our business to have this feature, but I think it's too expensive. And you're like, no, we have that. We just didn't turn it on, right? So sometimes you'll do these. Top-down estimates. Top-down estimates are kind of looking at the outline of something, comparing it to things you've done before. We'll talk about those. And we'll talk about bottom-up estimates, which are the most robust, but the most work. So the first example of a SWAG, one second here, is a Fermi estimate. There's a great XKCD on this if you Google Fermi estimation. So these are for when you're trying to get the general size of, with pretty big variance of a project to help you figure out if it even makes sense to do. Let me tell you a quick story. So Enrico Fermi was an Italian physicist. He's kind of considered one of the fathers of the atomic bomb. He was a specialist in quantum physics and nuclear physics, stats. He won a Nobel Prize before he emigrated to the United States. He observed the Trinity bomb test. I'm going to read a little bit here. Oh, go back. The Trinity bomb test in 1945. And this is the first nuclear bomb ever detonated. He did a quick estimate of the strength of the bomb explosion. So these are from his notes. About 40 seconds after the explosion, the air blast reached me. I tried to estimate its strength by dropping from about 6 feet small pieces of paper before, during, and after the passage of the blast wave. Since that time, there was no wind. I could observe very distinctly and actually measure the displacement of the pieces of paper that were in the process of falling. The shift was about 2.5 meters, which at the time I estimated to correspond with the blast that produced 10,000 tons of TNT. It's the first nuclear bomb, right? So no one has a model for this. Some people thought that the atmosphere would vaporize and we'd all die. He was off. It was 18 kilotons of TNT, but that's not that far off for something that's never been done before, right? He had built a chart and made some assumptions about how a blast wave would spread, the air resistance and things like that. And then he made some quick measurements during the blast and looked at his sheet. Apparently he was so fixated on his sheet he didn't hear the blast wave. So Fermi estimate, here's an example. This should be readable on this big a screen. The classic Fermi problem is how many piano tuners are there in Chicago? You make a bunch of assumptions when you're doing this. You say, let's assume there's 9 million people, right? That seems reasonable. Let's assume there are 2 people in each household on average. One household in every 20 has a piano. If a piano is tuned regularly, that's about once a year. And it takes a piano tuner 2 hours. So these are all assumptions. They all seem reasonable. And each piano tuner works basically a full year. If you make those assumptions, and you've covered the work of a piano tuner, so you included travel time, and they have weekends off, right? You come out to 225 piano tuners in Chicago. Wolfram Alpha reported that in 2009, there were 290 piano tuners in Chicago. It's not that far off, right? The way you do this is you make high-level assumptions. You make assumptions that cover all the pieces of the work that you have to account for. You approximate everything. So you're not going to say you have 9,832,000 people in Chicago. You don't have that precision. So you approximate everything. You combine them. And then like Fermi, you win a Nobel Prize. So let's apply this to a software problem. let's look at, we need to do a design phase. So we need to interview a bunch of users to figure out what, they want to automate some stuff. Let's say they're going to do reporting and they want to replace some spreadsheets with reports or something. We want to figure out how long that design phase will take. So we might say, okay, there's approximately 20 stakeholders. Each interview will take about 30 minutes for them to show me what they do, give me a copy of it. Documenting will take about 2 hours per, because I need to maybe do some screenshots, I need to write up some stuff. We'll average 3 interviews a day. People are busy, they don't have a lot of time. And we'll have days where we just can't get any interviews. We'll say 25% of our days. We do the math, we say that ends up being 3,000 minutes of work spread over the course of 6.25 days. And to account for the 25% of the time we're not working, we can work this out to be about 8 and a third day. This is a reasonable use of an estimation like this, right? We can say, hey, we think this discovery phase, which there's a lot of things we don't know, will take about 8.25 days, and here's why. If it turns out there's 30 stakeholders, you can go back to the business and say it's going to take longer, and here's why. And you signed off on my assumptions, and so it's going to take longer, and there's nothing I can do, right? Good for that kind of estimate. Pros and cons, they're really quick. It's a big pro. You're making a lot of assumptions, though, so your precision will suffer. So you're going to only be as accurate as your approximations are, and you're multiplying them all together, right? It's great. This is the closest to back of the envelope you should ever get. And if you document this and get sign off on your assumptions and they're wrong, you can kind of cover yourself. So next thing, top-down estimates. And if you want any of this stuff, I'll put the URL and the slides up on my website afterwards, jaredthenerd.com, and I'll put that URL up. Top-down estimates are called analogous estimates or parametric estimates. Let's show you the city of Chicago to stay on the Chicago theme. Example of an analogous estimate might be, let's say you own a cleaning company, and you clean one of the skyscrapers. You clean, I don't know, you clean that one. And it takes a certain size team, a certain number of hours to clean the thing. If somebody comes to you, and let's say you know the square feet, a few other things. Somebody comes to you with another skyscraper and wants to just kind of generally know how much it'll take to clean. You might not even have to do a walkthrough, right? You might say how many square feet, how many floors. And you might be able to say, within reason, how much they'll take to clean, right? Because you're comparing apples to apples. You would not necessarily say, if you're cleaning houses, you would not necessarily be able to estimate how long it takes to clean a skyscraper, right? So top-down estimates are looking at analogs that you have and comparing them and trying to get a reasonable cost or schedule estimate based on the outline of a project. So the steps to a top-down estimate: identify the size and shape, look for analogs. These work best if you're comparing similar projects, similar sized projects, lines of code, time, whatever. Apples to apples kind of works. So similar sized projects are good. Apples to pears, things that are kind of close but not identical work. Apples to chickens doesn't work, right? So if you always do custom app dev and somebody asks you for an SAP implementation, you're not going to be able to do this, right? Identify where they're alike and unlike. Where they're unlike, you might decide to do a bottom-up estimate, and then size the project relatively. So I'm going to read this. This is a quote from the software estimation book. In the book, Steve McConnell talks about the effort. Not a quote, but he says the effort increases exponentially, not linearly with project size. That is, a project twice the size is not going to take twice as long. It's going to take longer. Then he cautions that you should only do analogous estimates when projects are close in size. So the reason for that is that there's a lot of other things that get added in as a project scales up. And you can't just say 10 one-month projects would take as long as, if you do one project 10 times their size, it's going to take 10 months. It'll take 14 months or something like that. Here's an example of why. If you're doing a project with 2 stakeholders, right? Let's say you're one of those and there's a stakeholder. You have one conversation to have, right? You have to talk to one person about the features you're doing. If you add another stakeholder, now you've gone up to 3 conversations, right? So you have to check things. The feature you want might break the feature you want, and I have to compare those. You go to 4, it's even worse. Now you're up to 6 conversations, right? All sorts of things in software scale like that, where the bigger the project is, the more each piece costs. So here's an example, a fictitious example. Let's say we're all one big company, and we do custom software integration. So we sell some piece of software, Acme Co-inventory or something, and we integrate with third-party providers. And we've done this a few times. We can look at the integrations we've done before and see how much those projects cost if we have good data. So let's say we have 5 different project examples. We could figure out an average cost per estimation, or we could do like a least squares regression and say, okay, in general, if somebody wants 10 integrations, it's going to cost around $900,000. You could do more than this with data. You could figure out work and time. But you could look at things, you've done this a bunch of times and compare them, right? You might eliminate outliers. You might have a project that was a disaster or it cost a lot more because you had to fly to Alaska every week or something. So you can look at this and you can eliminate outliers if you're doing the same types of work. In iteration planning, we kind of count on this, right? We're saying, okay, we're going to size things as XL, as small. If you've never done it before, let's say there was a question about that at the beginning. How do you size it like that, right? You said, okay, we normally do data grids and forms. We're enterprise, grids and forms, that's all we do. And a navigation header once in a while. And somebody wants us to build a mobile app. You can't just say it's a large, right, or an Excel. You don't have any context with that. Top-down estimations don't work particularly well then. That's when we want to look at the actual detailed estimate. So at the iteration level, as long as you're doing things over and over, you get really accurate. And you should see kind of your estimate and your reality merge, but not with the big deltas. So use these tools interchangeably. So top-down pros and cons. The estimates are really valuable when you have good analogs. If you do the same type of work frequently, they're quick and they should be accurate. These are still fast and cheap to perform. They might be, even if you're going to do bottom-up, these might be a good place to start as a sanity check, right? But if you don't have good analogs or totally different types of projects, you can't rely on these. These account for all the different types of work we talked about because the last project accounted for all the different types of work, right? So you're going to look at actuals from a previous project. If you're tracking it correctly, all of the work that happened in those projects needs to be in those actuals so that it gets reflected in this one. So you're kind of implicitly accounting for that work, right? So top-down makes sense. Now what? This is the meat of this, right? Here's the hard part, is bottom-up estimation. This is where the work comes in. So let's say I want you to estimate how long it'll take to build that car. Right? How much will that car cost? Knowing it's a Prius, you might have a guess, but this is really hard, right? Looking at a software project and trying to guess all the complexity of it is similar to that. Even if you know automotive parts, that's a lot to just kind of internalize and estimate. So what bottom-up estimation does is it relies on breaking down the project into components, small components that you can reliably estimate. I'll say widgets, right? You're going to build different widgets. They could be anything from workflows to forms to navigation pieces to graphs to API integrations, just things that you could build. They should be things that your team can identify with. So things that your team would agree they build regularly. You're going to use this again as communication, which we'll touch on a little bit later. So let's say with the car, let's say we work in the automotive field, we work for like Delphi or some parts supplier, and we generally can size individual things. What you do is you'd start with a piece. So we'd say, like, take the chairs. You might say, okay, those are vinyl. They have a flip-down arm thing, but no cup holders, so that makes them a lot cheaper because cup holders are expensive, high tech. And it has seat belts. It's got a child restraint. Okay, maybe I can say, we've built these before, and these cost $1,000 or something like that. And you could do this for the rest of the car. You could go through and say, okay, let's look at the muffler. What are the different pieces, right? And you start at the bottom, and you start to add things up. So that relies on you having expertise. This is not a role for a junior person, right? You have to have built things. And if you have good records, especially, you can go back and say, okay, the last time we built a data grid that had somewhere between 10 and 15 columns, it took us 4 hours. Is there a question in the back? Or just, no, sorry. You might say, okay, we use an off-the-shelf component for this. Assumption, we can use that component for this next piece. And if we do, it'll take a certain amount of time. So let's talk about the steps of bottom-up estimates. First thing first, break down the project into smaller widgets. And I'll go through an example project here in more detail than we did on the previous ones. Estimate each widget. So, like the chair, you say, okay, well, let's get it down to the smallest piece that we can estimate. In the chair example, it might be smaller. It might be each seat and each seatbelt mechanism. This will be kind of up to your team. I like at this point to have my team poke holes in it, right? Have somebody else look at this and see, are we missing whole types of widgets? A common one would be we're building different screens and no one's accounted for navigation. Or you put a data grid in and there's some mechanism for adding things, and a team member might say, every time we build these, they need a delete mechanism. And the client always wants like an undelete. They want a screen where they can show all archived items, right? So they can catch widgets you're missing. So you get all those widgets, and then you add them up, right? You say, okay, give me all the pieces. All of these should be traceable back to your individual decisions or to your individual scope items. So I'll show you this in a document here in a second. You start with scope, right? So you have a document, I'd say like a Word document. It details all the features. Now you said, okay, what types of things build that feature? Tie them to the features. If you come in and your estimate is way past the schedule that you need or the budget, then you can go back to the user and say, hey, if we can cut out this kind of logical chunk, we can cut out all of these things and all the work associated with them. So you add up the estimates. Let's go through an example. So our software company, we have Acme Co-inventory again, and we're going to integrate with a bunch of third-party web references. So I write a scope document. In the scope document, I detail technical assumptions I've made, the platform it's going to be on. I detail the integration points, and I say, okay, we're going to integrate with the get all shipments endpoint, and it's going to do a few things. It's going to return an object. We assume it's this format. I link to, if they have documentation, I link to their docs and say it's going to work like this. If it doesn't, I can point back to that. I number it, right? I might even number further. I might number these so that later on I can tie stuff back directly. And I get them to look at this and I get them to agree. So each time we're talking about the same thing. If they say, yeah, but what about this screen? And it's not in there, we're going to have to re-estimate and get that back in. So now you said, okay, what are all the things I need to build? You can kind of make a list of this, right? So here's all the pieces we need, right? So you have your assumptions, you have your constraints in that document, and now you start building out the stuff you'd build. So for this inventory, WCF endpoints and maybe some models, and maybe it uses EDI, so I have like this document contract to make, and there's error handling, and there's caching, and you can size these. So if these are small enough and you've built them time and time again, you can sort of say, hey, when I make a WCF call, assuming that it works like this other provider, because they both say they use the same standard, I can implement that in 2 hours. Or I can implement that in 8 hours or something like that. Base this on your knowledge. I like to use hours here because that's what you're trying to communicate to the business. You might start by sizing things in just t-shirt sizes, but at some point it has to be converted. This gets better as you get better if you track your data, so I'll keep repeating that. And it's worth noting the numbers don't generally scale linearly. So simple things in software development are really, really simple, right? And complex things are not just slightly more complex. They are way more complex. If you can break things down into enough simple pieces, great. That means you've thought through the design. If you can't, the numbers will usually be a lot higher. For this to work too, it means you're designing the software at this point, right? You're spending enough time modeling the software, how it's going to work, how you're going to build it, how you're going to architect it, that you can come up with these widgets. So it's not, you're starting to think, this is why you have to be senior, of solution, right? So the other ones were the problem. It's I need to clean this office building, or I need to estimate how many piano tuners there are. This requires you think through solutions. So your implementation may be different, but in general I found if you've thought through the solution and thought through all the things that need built, even if the approach changes, the team will generally do a similar amount of work and cover a similar number of things. So maybe you don't use WCF for your web service and you use a RESTful API or something. They still are going to have to do some of that work. So this requires solutioning. It requires work, right? So I do these documents. At this point, I'm doing data flow diagrams. I might even be doing screen wireframes. I do the wireframes to make me catch all the things, right? So I put together the grid, and I realize, hey, it's going to need to have a show deleted items because the client always wants that. Then I go through my wireframes and I make sure I kind of mark off, like sometimes with a physical highlighter, did I account for all the pieces? So a lot of work, get to your numbers. Complex stuff tends to be really complex. You add this up. So I put this back in the document and you can see, okay, this feature is going to have one WCF endpoint, it's going to have 2 of these tracking things, the items don't matter, but it's going to have all this stuff. You add this up and you get the build. So this is development, right? We haven't accounted for testing, requirements gathering, we haven't accounted for deployment, we haven't accounted for support, just development. So what about the rest of the work? And when I set the slides out, there'll be a link in here to how do you estimate the other parts of project times. But we figured out that there's a lot of other stuff. We talked about this earlier, right? A lot of other tasks. How do you estimate that? There's 2 ways, really. Estimate it precisely based on the work. So in the case of if something's you've done regularly, you might know that you always need a 1-week testing cycle for that, right? You've done it a bunch of times. So you could look back at your historic data and know. And so maybe you would list out every single role, and you would plug in an estimate for each role. And if you have the data to do that, the knowledge, great. The other way to do this is based on ratios. So you say, okay, in general, when we do development, we need so much testing. A common number for managers is like 10%. A common number for reality is like 100%, right? Including bug fix and things. So if there's 100 hours of dev, it might very well take 100 hours for somebody to test to write test cases, to test the test cases, to give you bugs, for you to fix the bugs, right? Your team may vary. If you if you have a lot of rigor in development, the testing may decrease some. But you could use ratios. Here's an example. In the slides, you can follow the bit.ly link. This was a company's estimate. So they say programming, development is 30% of the project. Design is 20%. So they probably rolled up business requirements in there and visual design. Testing is 40%. So they have testing larger than development, right? Which could be really reasonable. They have documentation, which probably includes some training things. And then they have produce CD, right? They're doing something physical there. You could say, okay, plug in my development number. You could work out the rest, right? That's just math. There's other methodologies. One's called 5D. So define, discover, design, develop, deploy. That one's a really common one. And you'll find slides on the internet where people have the ratios they use for that. If you can look back at previous projects, you might be able to build your own by just kind of adding things up and carving it up. In general, the goal here doesn't matter the methodology. The goal is to account for all of the work that has to be done in your project. So ask your teammates to poke holes in it. Ask them to say, hey, did you think about testing? Hey, did you think about, I don't know what Stan does, but he's here and he's always busy. So what does Stan do? Make sure that's in the project, right? Make sure you're accounting for this. So this will kind of communicate with the team what you're trying to accomplish and make sure you're not missing things. In the iteration, this should be pretty easy because you're going to pretty quickly turn stories into tasks, right? So you're going to start cutting things up into individual developer items. This should be easy to add those up at that point. That said, your team may not be structured in a way that accurately reflects the work that has to happen. So I would argue there always is requirement gathering. There's always testing. You could be a team of just developers. Someone's going to wear that hat, right? If you're measuring it like this, it's useful for communicating to your manager if you need more people or why things take so long. So your manager may look at a team of 3 developers and say, 3 developers, 40-hour weeks, I have 120 hours of development I can get done. But if they're wearing the BA and QA hats, you don't, right? So you could carve this up and say, okay, realistically, how much active development could we get done? That's really, really useful. You could go back and say, hey, we could use actual testers because this is the work, right? The term we'll use is the work is the work. It's there. Somebody's going to do it, and you might be able to use that as ammunition if you're arguing for different types of roles in your team. Who here would say they have a good balance of development to QA? That's the one I see struggle a lot. Who has no QA? Okay. Who here has something like 1 QA person for every 5 developers? Right. Okay. Who here has something like parity? Anyone? Where it's like 1-to-1 or okay, something closer, right? Then I'm not sure what's right, but generally when you have like a development team of 10 and 1 QA, there's something wrong and other people are doing QA work, right? That might work well if you have developers with good attention to detail, but thinking through these ratios may give you a way to kind of argue for more from your team. So pros and cons. The biggest con is this takes a long time, requires thinking through problems, building a solution. If you're doing, who does consulting again? Who's involved in kind of the pricing of consulting? Anyone? So whether you are or not, it's worth knowing that this is the kind of work that generally costs money, or it's work. So if you give somebody a high order of magnitude estimate, that might not be. If you do design and architecture and process, that a lot of times is work and it's paid for. Internally, that a lot of times is not accounted for by a team. So management might say, okay, we're going to do this $200,000 initiative, and they don't think about the fact that there's another $50,000 or some, I don't know what the number is, of work that's going to have to happen. So having this kind of model that everyone can point to is useful for communicating what the cost of things are going to be. So biggest downside is time, but the biggest upside should be precision and accuracy and traceability, right? You can tie things back to your scope. So what about risk? What about the things you don't know? Question in the back.
Would you say it's fair to say that from bottom up that you really have to have a somewhat known scope? Because I feel like when you get down to the level of detail that you're talking about, you already know kind of what the parts are at that point.
Okay, so the question is, when you're doing bottom up, do you have to have a known scope? Do you have to kind of know what the parts are? Is that a fair? Yeah. Okay. So yeah, absolutely. And that's why I like to get somebody to sign off on it. Whether it's formal as a contract or not, you can't estimate until you know what you're estimating, right? So you do need to know what the parameters are. We'll talk about re-estimating. They can change, but if you have the base one, then you're just talking about deltas, right? So you can say, okay, what we had before, now you've asked for this scope, here's what it's going to change. And you have traceability from the initial project all the way through what you actually build. But you absolutely have to know what the scope is. Any other questions before we move on? Okay. So let's talk about, we're talking about risk. So we're not guessing here, right? You're starting a project and you're estimating before you've built it. You have absolutely no risk when the project's over and you've delivered it. You can give a perfect estimate. But at the beginning, you can't. So what we want to do is provide the most accurate estimate of how bad our estimate is, right? So we're trying to accomplish. We call it contingency as well. So this is, like I said, our best guess, and we generally base it off of historic knowledge. So in my company, we've done a lot of projects. We kind of know the range that our things fall into, and I'll talk about that. You might be able to look at your history. So here's how we can estimate that. So look at your assumptions. So all the things you said, these need to be in place, and maybe some of your constraints. Figure out which ones are external. The external ones are things that you can't possibly account for in your estimate. So if you're told that this API is a standard and you're going to build to it, and it's totally a lie, your estimate's going to be wrong and there's nothing you can do. You don't really need to account for that. You can try to, but it's not going to be good, and I would account for it separately. Your internal assumptions, the ones where you said, our team will be able to do this thing, a new technology that you've not used before. Like let's say you're replacing one set of controls with a brand new set. We know how to use controls. We're assuming that there's only so much ramp up we can do that. Those ones you account for in the risk. You need to look at the likelihood of the risk of the problem happening and the impact. So if the impact's low, we can go back to the old controls if the new ones don't work. It may not affect your risk that much. If the impact's high, the company goes out of business if this is wrong, you need to account for that. Determine your risk level and then use 30%. This is a lot of companies use that plus or minus 30%. That tends to be about right for us, but it varies by company. That's just to give you an idea of kind of the range people tend to think in, like 20 to 30% is common. But you really should look at where your company is. So the risk is the risk. It exists on every project. You're trying to account for the stuff that's internal. So you're going to commit to a timeline, right? And you're going to be held accountable if you don't hit that. If somebody in the team quits and you have to ramp up someone else, the product owner may not care, right? Or somebody's sick and you have to slide somebody in from another project. Maybe you have a product owner you can convince that's okay, but a lot of times other people have committed to things because of your deadlines, right? There's a trade show and we've said we'll have features in place. By having contingency called out and accounted for, you can deal with that, right? So you said, okay, we'll have it, you said internally, we'll have it done in 10 weeks, but then you said, well, we're going to add 30% to that, so 13 weeks is what we're committing to. That gives you time to fix some of these problems, right? In consulting, if you're doing, there's different types of models in consulting, and I'll just be brief because a lot of people were not consultants. If you're doing time and materials work, that means the client owns the risk. So you've told them, hey, we think we can get 10 weeks done, but if something happens, it might slide. If something changes, it might take longer and you're going to pay for it. Consulting companies that do fixed fee work, they have to own that. So they say, you're going to pay for the risk, and if we get done early, good for us. So the risk is there, and it should be communicated so stakeholders know why the number's there. So it's not padding. We're not saying, hey, developer, how long does it take? Oh, you said 2 hours? I'm going to say 6, right? You're going to actually work through and have a model for this. So developers would like to go with 100%, right? Well, you said it's going to be 10 weeks. Let's just commit to 20 weeks or a year. Well, let's not commit to anything. Bosses don't seem to like that. So I've talked about this a couple times. So estimates as communication. Estimates are useful for a few things. Describing what is and is not included, right? So if you have some sort of documentation you can trace through, if somebody comes back and says, why is that feature not there? You can say, you never agreed to build it, right? It's not part of our timeline. We can still do it, but things change. Pushing back on unrealistic plans. If you don't have an estimate, and how are you going to know that something can't hit a certain deadline? With an estimate, at least, you could go back and say, hey, we don't think we can get to that time. Are there phased releases we can do? This is a common one, right? They want all these features, but they really don't need them all by that trade show. Can we prioritize, right? It's hard to do that if you don't have some sort of estimate. They're useful for communicating team needs to management. So I talked about if you look and say, hey, we think that there's 10 hours of development work and 10 hours of testing work, and we don't have any testers. You suddenly have some, maybe not data, but like logic behind your number, right? You're not just saying, I think we need more testers because the guy at the conference says we need more testers, right? You've thought through something. You can look at previous projects and say, 3 of our developers did nothing but testing for a week. They hate it. They're going to quit. You have some metrics now. And it's good for communicating business goals to the team, right? So you've gotten the business to tell you what they're trying to accomplish, to hopefully cover, like in your scope, talk about timelines and priority, and you've talked through with everyone what you're trying to do and when, how, and why. The team, if they're on the same page, you're going to do better work, right? They might spot things that can help you hit that deadline, right? Oh, we don't actually need to build this whole thing until the next release because this feature isn't necessary. And they're really, really useful for explaining the cost of change. So scope is going to change. Things come up, right? There's a fire of some sort and you have to respond to that. Or there's a new feature that they need because a competitor released it. if you have an estimate, you can go back to that and say, okay, I got pulled aside to do bug fix for the last 2 weeks. So my hours have dropped. That means the timeline's going to go out because we estimated there's this many hours of work and I didn't get to do them, right? So you can use that to explain the impact of changes and sometimes to cause changes not to happen, right? If they think they can get the change and they'll just slide right in, they'll ask for it, and you say, hey, it's going to cause us to push the date by a week, they might say, I actually don't need that at all. This is fantastic for really wishy-washy people who they want something built, and the minute they see it, they want it changed, and they're going to go through 20 iterations. If you can communicate impact to them or maybe their boss, who is the one really footing the bill, you can sometimes just cut that off entirely. So you're not done estimating just because you've gone through this once. They need to be refined anytime you discover new data. So perhaps you finished the first release. Look back at the lessons you've learned, right? Did the first release take less time or more time than you expected? What does that imply for the rest of the project? Re-estimate. I can't think of a business owner who would not prefer to know that there's a problem in the initial estimate early in the process than late, right? You don't want to tell them because you hope you can recover, but you're almost always better communicating it early. And you need to be recording accurate data, right? So this is why people use project management tools to be able to do that. So have some way of estimating this and track it. And you're not going to get this on your first project. So in summary, estimation is a skill, right? This is something you can get better at. Hopefully you've learned a few tips today and walked away with something, but it's something you can get better at. There's books you can read. There's articles you can read. You can talk to people who do this. Account for all of the work in a project, right? There is a lot more work than just development. Make sure you're accounting for it. Don't pad. Risk is a thing. We need to account for it. Call it out. It's something you can talk about and explain. A lot of business people don't understand software development, right? To them, it's black box. If you can get them closer to understanding what you do day to day, they'll understand why things go sideways. And they're going to be a lot more reasonable about changes if they understand that. So use this as a communication mechanism. Communicate what you did and did not estimate, right? Be able to go back and say, it's not there because we just didn't agree to it. And don't panic. You can do this. Any questions? We have a few more minutes left. Yeah.
If you know you're going to have to ramp up a new developer, for instance, we have co-ops, and how would you build that in? Would you do that in ratio?
Okay, so the question is, you know you're going to have to ramp up someone. You're going to have co-ops or interns. How do you build that in? You can do it a few ways. You can, I generally size things based on kind of like the average person on a team doing the work. But you could apply like a ratio to your sizing and say, hey, we think they're going to work on these tasks, right? Or you could say, hey, we're going to add an onboarding like line item. We're going to add another ratio for that to account for it. I guess my answer for most of those things is it doesn't really matter as long as you account for it somewhere. So you'll get to the end result, right? So just make sure that somewhere in whatever model you build up, which when I say model, I mean spreadsheet usually, that you just have something accounting for it. And your team should kind of agree it's reasonable. So if you do a ratio, look at the hours, make sure the hours that come out of that are reasonable. But as long as it's accounted for, I don't think it necessarily matters how. That's why I haven't really shown a particular like tool, because you could build this a lot of different ways. Other questions? Yeah?
What if you had a risk that's calendar time but not actually development time?
Okay, so what if you have a risk that's calendar time but not development time? Like somebody else has to do something at a certain time? So that's something, you would definitely want to call that out as an assumption or a constraint that needs to be in place. And then probably call out what the impact of it not being is, right? So I think that's a communications thing, not as much estimation. Although if you can prioritize your tasks to minimize that somehow, that's useful. But I think that's more of a communication task. Just make sure it's accounted for somewhere. And the nice thing about that document is you can like highlight stuff in yellow that somebody has to read because they'll skim through most of it, and make sure it's communicated. Any other? Yeah.
If a project is large, say like turns out to be 6 months, and you need to account for all of the work of the project, how would that still fit with Agile?
It's tough, right? So the question is, if a project is really large, you need to account for all the work. How does it fit in? You're going to have a lot of assumptions, right? Things are going to change. You're going to have to account for the fact that your estimate is going to be wrong. But your hope is to have enough precision somebody can make a reasonable decision based on that, right? So you think through enough of the design to do an estimate and call out all the things where you're like, I'm assuming we do this, I'm assuming we do that. And then because you have that, when stuff starts changing, you can trace it back. So then you do regular check-ins and say, hey, based on what we've done in the last 2 iterations, what are the impacts to our schedule and budget? But now you have a basis, right? So you're going to have change. Even if you're not doing Agile, you're going to have change. But now you have a mechanism for kind of communicating what that means based on some, I guess, initial thing, right? You can talk about deltas, where if you have no basis, it's really hard to communicate that. So yeah, just assume it's going to be different, and then as quickly as you can, make sure you communicate what changes. Yeah.
What if it's technology that you already have not used yet? Just additional risk for you?
You could account for it in risk. Technology, the question is technology that's new that you haven't used. Account for it in risk? Yeah, or you have, okay, so it's not new in general, but it's new to you. You could account for it in risk. You could account for it with some training time. You put training in there and say, hey, we think, and you might be able to estimate that realistically, right? We need to spend a few weeks to build a prototype or something. I guess find a place in the model where you can account for it, and then do your best guess of estimating what your ramp up is. And that's probably the best you can do.
How do you figure out what part you need as an investment in your business and not pass on to the customer?
Okay, that's a good question. How do you figure out what part you eat as an investment? So you're thinking consulting, right? Or if you have a client, what part of this do you eat and not pass on? So some of that is sales, right? You're saying, okay, if you're treating your customer as a partner, you're not going to charge them for everything. Generally, I'd say like swags and top downs because they're quick. Those are like a pre-sales thing. When you're doing the next part, that depends, I guess. If you think you're going to have to spend months and months doing estimation work, you probably want to charge for it, right? If you think it's a matter of hours, your business might decide there's a certain amount that they'll invest in a project. I'm not sure that there's a clean answer to that, but you look at what the cost would be, and then you decide if it makes sense to eat that cost. Maybe in the front, because we didn't ask you before. Nate.
Rather than looking back at having a way to cover yourself, the example that Jared gave where I got pulled to work on some production issues, so the timing is going to change. When you have this documentation, you can say, look, you just asked me to go work on some production issues. That will change the timeline. Now the business has a choice, and a knowledgeable choice, an informed choice about whether they do want to retask you and what it's going to cost them.
Let me repeat that for everyone in the back. If you're pulled away on production issues and you have some sort of like schedule and scope and an estimate you've put together of your main features, you can say, hey, this is the impact of you pulling me away on production issues, right? Another thing, if you think it's reasonable, is once you do the estimate, allocate your schedule based on maybe 3/4 of your time being spent on this, right? You might be able to say, I know I'm going to be spending a day a week on production issues, so I'm going to build a schedule that uses the other days. So you might be able to account for that, yeah. Okay. Okay, the question is, how do you account for technical debt? Isn't it? This is tough. So I always do this. I always build my estimates assuming we're trying to build the best code we can in a reasonable time period, which is hard to define. I'm not sure how you account for that. So you might, if you're estimating, we have to get this thing out the door because our business is going to go under, you might say we can compress the schedule, but shift the cost, right? And the costs are later. I'm not sure how you do that in a model. That's tough. Maybe we can talk about that afterwards, 'cause I'm not sure. Yeah, question in the back. We only have about 2 more minutes, so.
So it's not really a question, but kind of a response to that. So the way I kind of look at technical debt is that you give it to them realistically. Like, okay, just so you know, we have this piece that we've been working on. You told me that priority-wise, that fixing this thing was not that high. Well, if we let it continue to build, it's going to get more and more expensive to fix later on. So I think it's a matter of making sure they know that it is a risk from a technical standpoint, and that eventually the cost of making that change will increase.
So just to paraphrase that, if you have to accrue technical debt, communicate what it is, maybe estimate what the cost will be later, or the impact will be, and just make sure the business understands that. As far as how you build that into a model, that's tough. So we have maybe 1 more minute, so right there in the red shirt.
Yeah, so I think part of the key is to try, and everything's tried, but not just how long is it going to take us to do this, how long is it going to take us to do this right?
That's true. You could actually build 2 estimates as well, right? What if we go into chaos mode and build this wrong, and what if we go and build it right, and then maybe estimate the impacts? So I think a lot of this boils down to how you communicate to the business what's actually happening on a development team, because it's not just a black box. They don't just give us money and then let us sit for a while and we produce software, right? So communication is critical. We're basically out of time. I want to thank you for coming. Thank you very much. I'll be hanging out by the H&B booth. If you have questions, come grab me. Thank you. And my URL up there, it's off. JaredTheNerd.com. I'll put these slides up. Actually, I had them set to post at 10. We'll see if they did. You'll be able to get to them then. So catch me at the H&B booth. Thank you. Yeah. I mean,